Hello everyone, I'm Aditya from Beatest and I'll be your instructor for the course Data Exploration in Microsoft Excel. Before we begin, let me ask you a few questions. Do you get impressed by fancy visualizations and charts? Do Excel functions and formulae daunt you? Are you not comfortable in using Microsoft Excel? If the answer to these three questions is yes, then you are at the right place. So let's begin. Let me first introduce myself to you. I am a BTech computer science engineer and an MBA graduate in the field of marketing and analytics. I am currently working with Latent View Analytics as an analytics consultant, and most of my work is around data analysis. Earlier, I have worked with Amdocs, Government of Andhra Pradesh, and lots of young startups like Healthmeet and Patentai. I have over 4 years of professional experience, and my experience includes predictive modeling, sales and demand forecasting, and sentiment analysis. All these 4 years, I have realized how important Excel is because I was using Excel in one way or the other. Now let us look at the importance of Microsoft Excel. Why Excel is so popular, why do people use it, and which all profiles and organizations make the most use of Microsoft Excel. So let's look into the key features of Excel. It helps in bringing data together so that we can perform data analysis and we can pull in data from multiple resources to perform data analysis or statistical analysis. It makes calculations very easy and quick. We can combine multiple rows and columns and perform calculations over them. Visualizations are very important when it comes to data analysis. When you want to provide insights to a client or your boss, you need to show them in the form of visualizations or dynamic dashboards. Excel provides a feature of dashboarding, and you can make multiple charts using slices and you can create dynamic dashboards in them. People using Excel can use advanced formulae like standard deviation, variance, net present value to calculate things which require time while manual calculation. And the most important thing, it is very easy to use. After completing the course and after practicing, you will realize how easy it is to use Microsoft Excel. Let's look into the applications of Microsoft Excel. It is used in financial modeling and accounting. Most of the balance sheets and income statements by big organizations are first created in Microsoft Excel, then they are published in public in some other format. It is used in data modeling and statistical modeling. You can do regression, you can apply hypothesis testing, and many statistical methods can be applied using Excel. And the basic data exploration part, which is a prerequisite for any data modeling, is done mostly on Excel. It is used for project planning by managers to allocate resources, to create budgets, plan the resources, how they are going to allocate it in the defined budget. And Excel can also be used for reporting. You can create very informative reports by making use of visualizations and dashboards in Excel. Let's look at the opportunities, which all job profiles require the use of Microsoft Excel. So data analysis, business analyst, product analyst, financial analyst, or I would say any job profile which makes use of data uses Microsoft Excel a lot. Knowledge of Microsoft Excel is mandatory for such profiles. Organizations like Moody Analytics, Boston Analytics, and other analytic firms make use of Microsoft Excel for their major work, and almost all organizations which are not related to analytics, they also use Microsoft Excel in their daily tasks in one way or the other. When I was a software developer in Amdocs, I used to work on Java and SQL, and most of you might feel that what is the role of Excel in the life of a software developer? I used to use Excel daily while giving statuses or while giving handover calls to clients. I used to use Excel because most of the people around me were using Excel, and you are no exception. You will have to use Excel. Let's look at some facts around Excel. Forrester Research have found out that 81% of the businesses use Excel. That's quite a lot. Understanding spreadsheet is a baseline requirement in nearly 80% of all middle skill job openings. 80% of all middle skill jobs require Excel. Now just imagine what would it be when you are applying for a high skill job. Excel would be a must. 78% recruiters prefer Excel proficiency in their candidates for an analyst role. In short, almost all high-paying jobs require a good knowledge of Microsoft Excel. In this video, we will see how this course is structured, what all topics we are going to cover, and what you can expect from this course. This course will be covered through 6 webinars over a span of 4 weeks with multiple case studies to solve so that you can do some hands-on in Excel and practice the things which are taught in the webinar. After all the webinars are completed, you will be given a capstone project. You will have a month's time to work on this project and it will be evaluated by Beatest. A certificate will be provided by Beatest after successful completion of this project. There will be a dedicated forum where you can ask any query related to the course or the capstone project. Additional mentoring sessions will be provided to guide you in case you face any difficulties during your capstone project. Now let's look at the objectives of this course. What should you actually expect from this course? By the end of this course, you will be comfortable with all the Excel features and most frequently used functions and formulae in Excel. You will be able to use Excel effectively to understand and manipulate data. You will get a good practice of solving real business problems by drawing real insights from the data. You will become familiar with visualization and different types of charts we can use. And finally, you will be able to make dynamic dashboards to present your insights drawn from the data. Now let's look at the content. What all things we are going to cover. We will be covering basic formatting, which includes quick selection, column and row width adjustment, text formatting, merging different cells together, table formatting, since table is most important part of Excel, conditional formatting, how you can format cells, columns based on a certain condition. We will be covering different formulae and functions like sum, average, standard deviation, variance, net present value, and many more. Logical functions like and, or, not. Basic functions and complex functions like VLOOKUP, HLOOKUP, match. Complex functions are really important when you are analyzing complex data sets. And nested functions as well. Nested functions is nothing but a function within a function. We'll be learning about pivot tables, which is very important when it comes to analyzing data in Excel. A pivot table looks like this, and it is used to group data by different variables. We can make customized table by selecting different variables which are important to us. We will also look at the different types of charts available in Excel, which chart is used when. For example, this bubble chart, which represents the number of sixes hit by different batsmen. The size of the circle increases with the increase in the total number of sixes. We can easily interpret from this chart that Chris Gayle has hit the most number of sixes amongst these 5 batsmen. Here is another chart called the donut chart, representing Virat Kohli's scoring pattern. This chart is similar to a pie chart, and here we can see that the Indian captain is fond of hitting 4s, as 35% of his runs in the first 7 seasons of IPL have come in boundaries. Now let me introduce you to the Capstone project. As I have said earlier, you will get a month's time to work on this Capstone project, and we will be providing you a data set containing data about each match played in the first 7 seasons of IPL. All the skills that you have learned and all the knowledge that you have gained in the webinars, in the course, you will apply all of them in this Capstone project. You will get enough hands-on practice, and this will enhance your experience in Excel. And also you will be analyzing performance of players in IPL. Interesting, right? Analysis of the scoring pattern of any batsman or finding the best bowling performance in IPL. This will not be easy, but don't worry. We will teach you how you can do all this and make it look easy. And this will be the outcome of your Capstone project, a dynamic dashboard. A dynamic dashboard looks like this, where you can see this dashboard is representing match by match runs scored by a particular batsman. In this case it is MS Dhoni. You can change the batsman whenever you want and the graph will change. So this dynamic dashboard is what we are going to teach you, and this will be the outcome of the Capstone project after applying all the skills that you have learned. Now let us look at the introductory video for the course Data Exploration in Microsoft Excel. And in this part we will look at the charts and visualizations Excel has to offer. We will look at the different types of charts available in Excel and which chart is used when. Not all charts serve the purpose, so we need to understand which one would be the best for our business scenario. So let's begin. You might be wondering why charts are important. Why do we use them at the first place? Let me answer this question. Our mind is more comfortable in interpreting information from visual representations. You don't believe me, right? Let's see with the help of an example. Look at this table. This table represents the daily sales of burger, pizza and noodles in a cafe. Looking at this table, you can draw some information, but you will have to focus on each entry. Like, the sales of burger is on a higher side in 2 days, on 5th January and on 12th January. Sales of burger is on a higher side. This is quite easily visible, right? But just look at the sales of noodles. It is more difficult to comprehend when the sales of noodles is higher and when it is lower, because the numbers are all in 3 digits and it is difficult to find the highest sale instantly. You will have to focus more and you will have to spend time. This is the limitation of data in a tabular form. You can't drive insights instantly. Now have a look at this chart. This is a graph, a line chart representing the daily sales of each product. Aren't the peaks and floors easily available? You can instantly see the highest and lowest points in the sales of the product. Like for noodles, on 3rd January and on you have the least sales, and on 7th January you have the highest sales. So it is instantly visible, and this is the reason why we use charts. In order to present your insights, in order to present the information drawn from the data to a third party, you need to use charts, because he might not be familiar with the data set you are using, and it would be way easier for him to comprehend the insights and information from a visual format. Now we'll look at the different types of charts available in Excel. We'll see which chart is used when and which chart is best suited for the type of business problem you are given. We are going to use the extension of the previous problem for understanding charts better. Have a look at this table carefully. We have added daily sales of products like coffee, tea and shakes in this table, and we are going to use this example further to see which all charts we can use to display different information from this tabular data. The chart we are going to look at is the column chart. Column charts are used when you want to display the information about what is the average sales of different categories of product, or what is the total marks scored by each section in a class. Technically, it is used when you have one categorical variable and the other variable as a metric. Now, what are categorical variables? Categorical variables are nothing but variables representing a category, like gender is a categorical variable because it represents male or female, two types of different groups. And similarly, countries, states, etc. can also be called as categorical variables. A metric or a continuous variable is one which is represented by a number and can be compared, like age. Your age and my age can be compared. Similarly, sales of a product. Sales is another example of a continuous variable. So this is how a column chart looks like. In our example, the categorical variables are product names, which consist of noodles, burger, pizza, shakes, coffee, tea, and the total sales of these products over the entire time is the continuous variable here. So this graph represents the total sales of each product for the entire period, and we can see that the total sales of noodles is the highest and the total sales of pizza is the lowest. So maybe this cafe is not making good quality pizzas. On the right, you can see there is another chart which is also called a column chart, but it is in a 3D format. You can make 3D charts in Excel. They look pretty, but it can be sometimes confusing because 3D chart is not recommended always. In order to provide information and in order to present your insights, you need to be simple. You don't have to give fancy charts. So a 3D chart can sometimes be confusing, since you can see if it is not clearly evident that what is the sale of pizza or burger from a 3D chart. You will have to focus more. But here you can easily see in a 2D chart that yes, it is less than burger is selling less. The total sale of burger is less than 2,000, somewhat around 2,000, and pizza is much more less than that. So two quantities, when you are comparing two categories, you should not use a 3D chart. And Excel also offers different shapes of charts, as in this is a rectangular column chart. So you can see a rectangle forming here. This is also a rectangular 3D chart. You can make cylindrical shapes, you can create pyramidal shapes, etc. to make your charts more attractive. Now let's look at a bar chart. A bar chart is exactly similar to a column chart. The only difference is that it is horizontal. A column chart is vertical. So this is an example of a bar chart. Here you can see that it is depicting same information what column chart is depicting. Analysts prefer bar charts over column chart when the number of variables are more. So if you see that here the number of products this cafe was selling was more than 10 or even more, then you can preferably use a bar chart. But both the charts serve the same purpose. This is an example of a pyramid, 3D pyramid chart in the form of a bar chart. So it is a 3D chart. It is again quite confusing when you see the sales of pizza and burger here. So we really do not recommend you to create a 3D chart. You should always prefer a 2D chart when you are comparing variables. Now we move on to pie charts. You must be familiar with them. They are really popular, right? A pie chart is used when we want to understand the share of one variable in the whole set. Like in this example, the share of total sales of burger is only 7% of the entire products, and sale of noodles here is 43% of the total sales in that cafe. So this graph is used when you can be used when you want to compare sales, when you want to understand what fraction of sales is being driven by a particular commodity. And similarly, not only for sales, we can also do it for other metric variables. Here it is a categorical variable. Burger, pizza, noodles, these products are categorical, and this percentage of share of sales is a metric. continuous variable. And here is another representation of a pie chart in which you can pull out one of the pies. Like here, I have pulled out a pie representing shakes, say share of sales of shakes. So 32% is the share, right? So in order to represent this information to the stakeholders or to for whom you are doing this project, you can always highlight a particular pie which is of interest. Whether if you are interested in the share of sales of shakes, then you can pull it off. So this is one variant of pie chart. We move on to the other variant. This is another pie chart which is quite different from the traditional ones. Here we see that this bigger pie is representing noodles, which is 43%, pizza 4%, burger 7%, and others 46%. What comes in others? Coffee, tea, and shakes, which is being represented by other circles. So, do you understand what is the utility of this variant of pie? This is actually helpful when you have more number of variables. Your single pie chart might only accommodate a limited number of variables. You can obviously make a pie chart out of 10 variables, but the person who is looking at that chart might not be able to might not be able to understand what you are telling, because the variables are too much. So, in order to depict information for a large data set, generally this type of a pie chart is used. Now we will look at line charts. Line charts are the most important and most frequently used charts in Excel. They are used to represent time series data like daily sales of a product or monthly sales of a product, match by match runs scored by a batsman, and so on. In our example, the daily sales of noodles looks like this. Now here you can see, except for the few peaks in the initial days, the sales of noodles is decreasing gradually. So line charts are used to analyze trend in a time series data, whether the trend is increasing or the trend is decreasing. You can conclude very efficiently from a line chart. This is a 3D version of a line chart. And looking at this line chart, you can see that it makes more sense than the 3D versions of bar chart and column chart. The 3D line chart looks less confusing, and you can draw same information from a 3D chart like you have drawn from 2D chart. But I would still recommend you to use the 2D version of it, as it is simpler to understand. This line chart represents the daily sales of burger and pizza, two products. So you can compare trends of multiple products or multiple variables of your time series data. Then sales of burger. Now, what if you want to understand the trend of sales in these products? It is very difficult to see that to comment on the trend, whether it is increasing or decreasing, because it's a mix of both. But still, you need to give an answer. You need to understand whether it is decreasing or increasing. So we use a trend line for this particular thing. Here is an example of a trend line, and you can see the green trend line is sloping downwards, which tells us that the sales of the burger is decreasing. And similarly, the orange trend line is also sloping downwards, which tells us that the sales of burger is also decreasing gradually with time. So a trend line is used to understand the trend basically of your sales in the entire year. Now we move on to area charts. Just like a line chart, an area chart is used to represent time series data. Like in our example, this area chart represents the daily sales of all the products in the cafe. The variables are color coded and you can analyze the trend by looking at the area. So just look at the area under the curve of noodles. This is blue and here we see is noodles. So by analyzing the area under the curve, you can compare it with some other products, say shakes, and you can see that shakes, the area under the curve of shakes is quite less than that of noodles. So that's how you compare sales of two products here in this area chart. What else we can conclude from here? We can also comment on the sales of pizza. Since the orange area is very less, we can say it is the least. Sales of pizza is least almost on all days. So this gives you information in terms of analyzing areas. So I would recommend you to use line charts. And analysts always recommend line chart over area chart since comparing area can be tricky sometimes. So here we can see the difference quite clearly, but sometimes when the difference is not distinct enough to understand, area comparison of area can be tricky. Let's move on to stacked area chart. The stacked area chart is used when you want to determine the share of sales in a time series, like in our example. Now, just see that the axis, y-axis has changed. It is now not representing the absolute sales, it is representing the share of sales or percentage. So, cumulative share becomes 100. That's why you see a rectangular shape where 100 is achieved. And here you can compare the share of sales. So, again, noodles wins the title because it has the highest, it has the largest area on the curve, and pizza has the lowest area on the curve, so it is the least, it has the least share of sales. So analysts prefer stacked area charts over line charts when you want to compare the share, or when you want to know the share of a particular share of the sales of a particular product or share of a particular variable among the whole set. Now let's move on to scatter charts. A scatter chart is used when you want to understand the relationship between two continuous variables. Again, continuous, I will explain what continuous was. Then you are comparing age, when you are comparing weight, height, all these variables are continuous in nature. One which can be compared, one which is metric. So I'll take a different example to show scatter charts. Here I have taken 20 students, height and weight of 20 students, which students are represented by IDs, and height and weight of each student is recorded. So now someone might ask me, what is the relationship between height and weight? To understand this relationship, I need scatter charts. It is very much used in statistical modeling, since scatter charts tell you the relationship between two variables. It is used in exploratory analysis of data. Again, the reason is you know that you understand the relationship between two variables. You understand whether one variable is increasing or decreasing with another, and so on. So let's have a look at the height and weight relationship. This is a scatter chart. This is how it looks. You can see the dotted points representing height and weight of that particular student. Weight is on y-axis, height is on x-axis. The point represents the particular student with that respective height and weight. So, analyzing this graph, you can understand that yes, height and weight is scattered along the chart plot. But you cannot. But it can be sometimes tricky to understand whether height is increasing with weight or not. In order to comment on this relationship, you use a correlation table, which is part of statistical modeling. you use a trend line again in this chart, like this. If the trend line is sloping upward, that means your relationship is positive, which means that height is increasing with weight. If it would have been the other case, if it would have been sloping downwards, then we could have said that height increases with weight. But this is not the case right now. It increases with weight. When we analyze the heights and weights of these 20 students. So scatter charts are very popular when you want to comment on the relationship of any two variables. Now we move on to bubble chart. A bubble chart is used when we have more than two variables and we want to extract information in such a data set. Like I have created an example. Here we want to understand the market of apartments, houses. So there are three variables which drive there are two variables which actually drive the price: area and distance from the main city. Area is in square feet, distance is in kilometers. So there are 5 sets of area in which the apartment is available. Distance is also varying, and the price is also varying. Now, just by looking at this table, it is very difficult to identify what is driving it. As in, if the area is more, ideally the price should be high, and if the distance from the main city is less, then ideally the price should be low. But you cannot comment on these two variables, area and distance, and compare how they are behaving together in terms of price. So in order to look at that information, you need a bubble chart. This is how it looks like. Here, area is represented along the y-axis. Distance from the main city is represented along the x-axis. The size of these bubbles is the price. So the size is more if the price is more. Hence, three different types of variables, which are metric in nature, can be we can understand the relationship between three of them from this single graph. Now, just did you see the trend? As in, what is the what is driving the prices? Why the price of, let's say, flat apartment number 4 is high? It's 100 lakhs. So why is it high? This is the 100th one. You can see it is only 1 kilometer from the main city, and it is 4,000 square feet. Now just look at the other one, which is here 7 kilometers away, but it is more than the area of this apartment. Still, the price is less. So yes, people are fond of living close to the main city. And this is why demand is high and price is high. So this is a simple market study. And this is a simple example which I have created to understand a bubble chart, which can be very powerful when we are understanding relationships between variables. Now we move on to stock charts. These charts are very powerful in predicting the fluctuations in stock prices. Let me give an example. This is stock price fluctuation depicted monthly, and the stock is holding power. How to read this chart? First of all, just look at the dates. It is a monthly fluctuation. So 31st July 2012, this reading of this data set has started, and it has ended on 31st May 2017. And it is a monthly data set. So how to read this chart? As in, first, it looks like a candlestick. One is transparent in nature in terms of, I would say it is standing upwards, and one is upside down. So the ones which are opaque, as in solid in nature, they have prices have dropped on that. It was opened here and it closed here. The highest price is denoted by the symbol right at the top. This is how you read it. This is the opening price, the peak of the big rectangle. The bottom is your closing price, and the point of your candlestick as a single line is the highest price. And let's look at this one, which is transparent image. It is closing here at the top of the rectangle. It is opening at the bottom of the rectangle, and this is the highest price. Single tip of the single stick. And this is how you read it. It is very powerful in representing stock prices fluctuation, as you understand when the stock price was high. It is you can call it a variant of a line chart. This chart is also a stock chart which is representing volume of stock traded on that particular month, and it is also depicting multiple information basically as well. Now at last we look at the radar chart. The radar chart is used when you want to display information about multivariate data. When you have more than 3 continuous variables, like in this example, where estimated sales are there, actual sales are there, and cost is there. There are 3 continuous variables, and we have used a bubble chart earlier in our example to represent such a relationship where 3 variables continuous in nature are present. But what when 3 or more than 3 such variables are present? Or what when a categorical variable is also present? Like here, a variable which is categorical in nature, product is present. A, B, C, D, E are the categories it is represented. So now I want to display information from this particular data. For this, I'll use a radar chart. Here you can see A, B, C, D, E. All these 5 categories are being represented as different sides of polygon. The estimated sales, actual sales, and costs are color coded and also have different sizes, shapes. Like actual sales is being represented by a square, orange in color. Estimated sales is being represented by a smaller square, which is green in color. A triangle represents cost. So, what can we infer from this chart? We can see that for product A, actual sales is more than estimated sales, and cost is less than actual sales. So we are incurring profit. And estimated sales is less than actual sales. That means we our marketing or our sales targets are being achieved. Then we go to the product B. Here again, the actual sales is more than the estimated sales, and the cost is less than actual sales. So we are incurring profit, and again our sales targets are being achieved. Let's look at product C. In product C, you can see that the estimated sales is more than the actual sales. So we are not able to achieve our sales target here for product C, and the cost is also higher than the actual sales. So we are incurring loss for this product. So ideally, this product is costing us more. And for product D, the estimated sales is again, there is a big difference between actual sales and estimated sales. Actual sales is way less than the estimated sales. So we have again not achieved our sales target for product D. And the cost is also higher. So here also we are incurring loss. And in E, although we are incurring profit, but we are not able to achieve our sales target. So this is how this information is we are able to get from a radar chart. And This can be very powerful when we have more than three variables. Like here we have three variables, continuous, image, and also a category. So there is another variant of radar chart which looks like this. Here the estimated sales, actual sales, and cost. All the three these variables have been color coded and are being represented by a polygon different in color. The blue polygon is cost, and we can see that this blue polygon is exceeding the orange polygon for products D and C. That means we are incurring loss. Similarly, if you look at the actual sales, which is the orange polygon, here the actual sales is exceeding, that is the orange polygon is exceeding the green polygon for product A and B. That means we are only able to achieve our sales targets for product A and product B. So this is how we infer information in a color coded polygon, and which is also a variant of a radar chart. So this is better than this one. This is my personal recommendation, but it totally depends on person to person which variant they want to use. That is all in charts. There are more variants available for each type of chart, which we are going to discuss in the course, and the charts can also be modified, which we can also customize according to the needs of the business problem. That's all in this video. Thanks for watching this video.